Hey guys, welcome back. In the last lesson we learned what is ARC, its structure, and how it's efficient when compared to RC file. In this lesson we are going to see how to create ARC file, key configuration properties associated with ARC, and inspect ARC files. Let's first create an ARC table. Creating an ARC table is super simple. Look at this create statement and look at the last line of the create statement, stored as ARC. That's all it takes to create an ARC file. Let's create the table now. First, I'm going to switch my database to file underscore formats. Next, let's go back and copy the create statement altogether and execute. Table is now created. Let's run a describe formatted command on the table. You can see here the SERDI input and output format are already populated as ARC SERDI, ARC input format, and ARC output format respectively. How do we load this table? We are going to follow the same procedure that we used to populate the RC file table in our working with RC file lesson. We'll use the select statement to select all the records from the regular stocks table, and with an insert statement, we'll insert all the selected records into the ARC table. Since the ARC table uses the ARC output format, the insert operation will automatically result in writing the contents into an ARC file. Let's run this insert statement now. This will result in a map-only map-reduce job, so let's wait for the job execution to complete. The job is now complete. If you look at it here, we have the number of mappers equals 2, which means each mapper will work on its input split and will produce one ARC file each. So we'll have two ARC files at the end behind the table stocks underscore ARC. Now this is the location of our table. So let's copy this location and do a Hadoop HDFS listing on this location. I'm going to say Hadoop fs-ls location. And there you go. We see two files here. Let's add up the size of these two files and see how well ARC did with compression and the file size. The size that you see in here is in bytes. If you add these two, you would get 87 MB. So let's look at the size of the RC file just to compare the size between ARC and RC. Here is the location behind the RC table. So I'm going to copy this and execute. Again, we have two files behind the RC table, and if you add these two, you would get 363 MB. Let's also look at the size of the actual dataset in plain text format. That is the size of the files behind the regular stocks table. So copy this Hadoop fs-ls command and execute. The size of the dataset here is 428 MB. So the original dataset is about 428 MB. The RC file is about 363 MB, and the ARC file is about 87 MB. So RC file is about 65 MB smaller when compared to the original dataset, and ARC file is 341 MB smaller when compared to the original. 65 MB size reduction with RC file versus 341 MB size reduction with ARC. That's pretty impressive compression with ARC, correct? And it is very clear that with default compression properties, ARC's compression and encoding is definitely better when compared to RC file. Let's make sure that we are able to query the ARC table. And here is a simple query to calculate the average volume of symbol B7J against our stocks underscore ARC table. So let's execute. And there you go. The result came out fine and all looks good. Let's now inspect the ARC file with ARC file dump utility. We have two ARC files behind the stocks underscore ARC table. Let's run the ARC file dump utility on one of those files. I'm going to copy this, and I'm going to execute this outside of the Hive prompt. So clear. execute. And here's the output. Let's now go back up a little bit. First, we see the number of rows. We have about 4.6 million rows in this file, and all columns are compressed with zlib compression. Next, we have stripe statistics, also known as stripe level index. Here, we have statistics at the stripe level for each column. This stripe 1 has data for about 2.6 million records stored in columnar fashion. You can also see it has the min and the max statistics for each column at the stripe level. Column 8 gives the statistics for volume column for stripe 1. Minimum volume in stripe 1 is 0. Maximum volume is about 329,786,100. So if we run a query with where clause for volume greater than 400 million, stripe 1 will be ignored completely. We also have similar statistics for all stripes in the file, and this file has only 2 stripes. Next, we have file statistics, also known as file level index. We have very similar statistics that we saw at the stripe level, also at the file level. You can also see some statistics, but some value in the statistics for non-numerical values doesn't make a lot of sense. Next, we have information about the stripes. First, we have information about the row level index. We can see the position of where the row level index starts for each column and the size or length of each. Remember, we have row level index for each column, and row level index is created for every 10,000 column values. Next, we have information about the column data itself, the size of each column and the start position of each column. If a column is encoded with dictionary encoding, we will see that information about that as well. Finally, we can see the encoding information for each column. Let's now look at the size of the stripe. Here is the size of the stripe. It's about 31 MB. The default stripe size is 64 MB. And from the last lesson, we know the reason why the actual size of the stripe is less than 64 MB. Because when ORC suggests the size of the stripe is 64 MB, what it actually means is the size of the buffer that is used to write the stripe, and not the actual size of the stripe on disk. So the buffer that is used to write is 64 MB. ORC, when it tries to write the file, it will gather all the rows, convert all the records from row format to columnar format in the 64 MB space, and then compress the data and write it to the disk as a stripe, which will eventually result in less than 64 MB due to compression. As you can see, we can find a lot of information about the ORC file with ORC file dump utility. Now, why don't we look at few important configuration properties with ORC? Here are some of the properties. Arc.compress indicates the type of compression. By default, each column is compressed using zlib compression. We can also specify snappy to use snappy compression, or if we don't want compression, we can specify none. Arc.stripe.size indicates the size of the buffer that is used to create the stripe. In more recent versions of Arc, the size of the stripe is 64 MB. In older versions, however, it is 256 MB. Arc row index stripe dictates the row group size for the row level index. By default, a row level index is created for every 10,000 column values in each column. Arc create index dictates whether we need row level index or not. Default is true. Look at this create table statement right here, and look at the last line. Here we are creating a table named stocks_arc_config. The configuration properties can be specified with the table property attribute. Here we are creating the table with snappy compression, and we are increasing the buffer size for the stripe to 256 MB. We are also instructing to create row level index for every 20,000 column values instead of the default 10,000. Let's go ahead and create this table. Copy this. Go back to the hive prompt and execute. Let's now run this insert statement to load the stocks_arc_config table. Copy and execute. Again, this will result in a map-only MapReduce job, so let's wait for the job execution to complete. The data is now loaded in the ARC table. Let's first check the size of the ARC files behind the newly created table. And here's the location behind the newly created table. So I'm going to copy this. So let's clear the screen and let's execute. Here, again, we see two files. The combined size of the two ARC files is 121 MB. The size of our original table, that is stocks_arc table, with the default zlib compression was 87 MB. And with the other configuration changes, the size of the ARC files went up by 34 MB. So at least in our case, the size of the ARC files were smaller with the default configuration properties. Let's now go ahead and run the arc file dump utility on one of the arc files behind the stocks_arc_config table. Go ahead and copy this and execute. Here's the output. Let's scroll up a little bit. And there you go. We see snappy for compression. And we also see only one stripe as opposed to two stripes from our first arc file. The reason is because we have increased the buffer size to handle stripes from the default 64 MB to 256 MB. Since we can now hold a lot more data in memory, we ended up with only one stripe. All right, so to summarize, we now know how to create and work with ARC tables. We saw a few key configuration properties and how they affect the size and structure of ARC file. We also looked at ARC file dump utility to inspect ARC files and see how the ARC file is structured. With that, let's wrap this lesson. See you in the next lesson.